Welcome to the video lecture series Microprocessor and Microcontroller. My name is Dr. Anilesh Day, Associate Professor, Department of Electronics and Communication Engineering, Narula Institute of Technology. This is my lecture 20. Today's lecture I discuss the priority of the interrupts concept of the maskable and non-maskable interrupt. First, I explain this thing with an analogy. Suppose this is one classroom. One teacher is written on the blackboard and student is sitting in the class and teacher is delivering his lecture. At that time, he just find out somebody knocks the door. Then what will happen? Teacher ask any student to please open the door. And when the student opened the door, teachers find it that the two students from the different class came into his current class and asked something. So teacher directly told him that you just wait for some time. After completing my class, come to my cabin, and then I discuss the matter. Now again, the student closed the door and teacher is starting to delivering his lecture. After 5 to 7 minutes, teacher finds that again somebody knocks the door. Again, the student which is sitting in front of the door, he opened the door and find it that the senior teacher of the same department is waiting outside in the room, and the senior teacher told the teacher that there is an urgent meeting called by the head of the institution. You must attend the meeting as early as possible. The teacher told the senior teacher that madam, just wait for the 5 to 7 minutes. I just complete the topic, then I'll move to the meeting. Then teacher again busy with delivering his lecture, and 10 minutes is over. He is also going for the just concentrated on this lecture. At that time, somebody is knocking the door after 10 minutes. When the student opened the door, at that time teachers find the head of the institute coming, and he told the teacher that there is an urgent meeting. I called you the several times, you not pick up my phone, and the senior teacher also asked you to join the meeting, is never go. Then teacher immediately stopped the lecture and leave the classroom and going to the join the meeting. So here you can find it out that when teacher is delivering some lecture, at that time the uh, uh, three interrupt is coming. One from the two students, then the senior teacher, and that third one, the head of the institution. But teacher give the first priority to the head of the instruction, and it is a non-maskable, because means that when the head of the institution called, the teacher immediately stop the lecture and move to the room. But teacher has an authority to giving the priority which one he can keep the maskable or pending, and which is treated as a non-maskable one. So this is the concept of the priority of the interrupt. Same thing going on the 8085 in the microprocessor executing a program, and multiple interrupts come at a time. Then microprocessor has an ability to decide it which interrupt is giving the first priority, which is the second, and which is the third, and so on. So which interrupt is a non-maskable? That means when the interrupt signal is coming to that particular interrupt pin, microprocessor perform his task and giving him the first priority. Then other interrupts which on the second one, here if the teacher thinks the student is the second priority, or the senior teacher is the second priority, according to teacher decided which one he can give the second and third priority. So this is the basic concept of the priority of the interrupts and non-maskable and maskable one. Now I directly enter into the subject. Multiple interrupts and priority. The question is, how do you allow the multiple device to interrupt using INT and line? The microprocessor can only respond one single signal or INT at a time. Therefore, we must allow the signal from only one of the device to reach the microprocessor. We must assign some priority to different devices and allow their signals to reach the microprocessor according to their priority. So what I explained in the previous slide, that is noted in this particular lecture in this particular slide. Now next one is the 8085 maskable and vector interrupts, RST 5.5, 6.5, 7.5. They are all the maskable. They are automatically vector according to the following table. The vectors for this interrupt fall in between the vector for the RST instruction. That's why they name like the RST 5.5. So this is the table. The interrupt name is RST 5.5, 6.5, 7.5, and these are called locations are the 002CH, 00348, 003CH, means that when the interrupt is coming for the RST 6.5, he just microprocessor compared his current execution and jumps to from the location to the location specified for the RST 6.5, that is 00348, where the in service routine is written. Next, I go for the one is a very important one is a trap. Trap is only the non-maskable interrupt. It does not need to be enabled because it cannot be disabled. It has the highest priority among all the interrupts. It is the age and level sensitive. It need to be high and stay high to be recognized. When it is recognized, it won't be recognized again until it goes low. Then high again. Trap is usually used for the power failure and emergency shut-off. So this is all about the trap. Now we come to the interrupt vector diagram. From the diagram, it is clearly written over there that this is the priority and trap is getting the highest priority, followed by the RST 7.5 second, RST 6.5 third, RST 5.5 fourth, and INTR is the last priority. And from this clock signal, it is written that the INTR is the level sensitive. It is indicating for the level 1. Trap is for the age and level sensitive. It is for the level sensitive, RST 5.5, 6.5 level sensitive, RST 7.5 is a age sensitive. Now I explain the diagram. This is the INTR. Suppose one signal is coming from the INTR, so it is 1. So it is the AND gate. If I go for the output is 1, then it is also working. That's why if it is a 1, both the lines should be the 1. So if this line should be the 1, this is also the 1. So this is the SR flip-flop, Q is 1, that means SR flip-flop is the set condition. So S equals to 1, R equals to 0. At that time it is the set condition. So it is 1, enable interrupt. And if it is a 0, OR gate output is 0, means all the inputs are 0. So it is a disable 1, DI, reset 1, any interrupt recognized? No. So when this one is coming over here, get RST code from the external hardware, what I explained in the last lecture. So this is the RST 0 location 00008, then 0008, 0018, RST 2, RST 3, RST 4, RST 5, RST 6, and 0038H for the RST 7. Now coming for the trap is the non-maskable interrupt. So when is coming the signal, a microprocessor directly go to the location 0024H. Now come to the RST 5.5, 6.5, and 7.5, or at the maskable interrupt. Here is a mask is there. Now what will happen? This is the AND gate. Output should be 1. So this is 1. So this is also 1. So this line input is a 1. RST 5.5 is 1. And this, what is the meaning of the mask? Suppose you have a bit 1. If I want to go for the mask on the bit, I make it the 0. So mask means it is a 0. So if the 0 is coming in this line and it is the NOT gate, so it is converted into the 1. So all at the 1, then output is 1, it jumps to the location 002CH. Similar for RST 6.5. Now for the RST 7.5, it is 1, it is 0, it is converted into the 1, and it is also 1. So output of the delay flip-flop is 1, so input is also 1. So why is needed for the 0 delay flip-flop? Because if I mask some, the question is coming for the pending interrupt. That's why the delay flip-flop comes into the action. So if all these three are 1, it is jumps to the location 003CH. So this is the all about the interrupt vector table, where I mentioned the what is the priority of the interrupt. Trap is getting the highest priority, followed by the RST 7.5, RST 6.5, RST 5.5, and then INTR is the last priority. Now I explained the one of the important instruction of the interrupt, which is the same instruction. It is the 8-bit long. D7 bit is other SOD, stands for the serial output data. If you want to send the data output serially, then this bit should be the one. SD is serial data enable. If this bit is 0, that means if we're not enabling the serial data, so how the serial data is going for the output? So if I want to go for the working SOD, so this bit must be 1. This is the don't care. This is the RST 7.5. The reset RST 7.5. If R 7.5 is 1, RST 7.5 is not allowed. If 0, RST 7.5, R 7.5 is allowed. MAC is a mask set enable. If I want to masking the 7.5, 6.5, 5.5, this bit should be the 1. If it is 0, this bit are we are not able to mask on that particular bit. So if I want to mask any of these 3 bits or all the 3 bits, so MAC should be the 1, otherwise 0. M7.5 reset for the mask 7.5, mask 6.5, mask 5.5. If it is 0, it is available 1 for the mask. Now there is a program. Set the interrupt mask so that RST 5.5 enable, 6.5 is mask, and 7.5 is enable. So I can first taking um, a, a same instruction format. I want to go for the 6.5 mask. It is 1. So if it is 1, MS should be 1. Rest of the 2 bits are 0, 7.5 and 5.5. And in this particular program, there is no mention for the serial output data or not. That's why these 2 bits are D7 and D6 are 0. So this value of the same is the 0 each. So first we go for the EI, then MVI A, 0 each, then we go for the same. This is a very simple instruction. You can simple program with the help of the same instruction. Now go for the REM instruction. REM instruction like that, it is also the 8-bit, and this is for REM instruction for the recognize for the pending interrupts. SID serial input data. If I want to input the data serially, it is 1. This 3 bit is for the pending interrupts. So if I want to go for the 7.5, 6.5, 5.5 should be pending. It should be the 1, other is 0. IE for the interrupt enable flag. 1 for the interrupts are enable, 0 for the interrupts are disable. And this is for the masking bit, M7.5, 6.5, 5.5. If it is 1, it is masked, otherwise it is available. So this is up to the REM instruction. Now we'll go for the summary of this thing. Interrupt name INT here, it is maskable yes, masking method DIEI, vector no, memory no, triggering method level sensitive. RST 5.5 and 6.5, I can discuss both at a time. It is a maskable yes, masking method DIEI same, vector yes, memory no, level sensitive. 7.5, it is maskable yes, masking method DIEI same, vectored yes, memory yes, it is a S sensitive. Trap, it is not maskable, so maskable no. Masking method, if it's not maskable, there should not be any masking method. Vectored yes, memory no, it is a level and S sensitive. Now we'll go for the next topic is called the pending interrupts. Since the 8085, the 5 interrupt lines, interrupt may occur during an ISI and remain pending. Using the REM instruction, the programmer can read the status of the interrupt lines and find if there is any pending interrupt. The advantage is being able to find about interrupts on the RST 7.5, 6.5 and 5.5 without having to enable the low level interrupts like INTR. So this is the concept of the pending interrupts. So the lecture 19 and lecture 20, this is all about the interrupts of 8085 microprocessor. So I discussed in these 2 lectures the What is a EIDI instruction, interrupts, generates the equation, RST generation with the help of the hardware. Then I can go for the maskable, non-maskable interrupt, priority of the interrupt, intervector table, rim-sim instruction, pending interrupts, and comparison of the all the interrupts. So this is up to this today's lecture. So I can end this interrupt over here. So this is my contact details, Anilesh day at the rate of IEEE.org, and this is my official ID, anilesh.day at the rate of nit.ac.in. This is the end of lecture 20. Meet you in the lecture 21. And last but not the least, if you like, then only you can subscribe my YouTube channel. Thank you very much.